A universally unique identifier is an identifier standard used in software construction, standardized by the Open Software Foundation as part of the distributed computing environment. The intent of UUIDs is to enable distributed systems to uniquely identify information without significant central coordination. In this context, the word unique should be taken to mean practically unique rather than guaranteed unique. Since the identifiers have a finite size, it is possible for two differing items to share the same identifier. The identifier size and generation process need to be selected so as to make this sufficiently improbable in practice. Anyone can create a UUID and use it to identify something with reasonable confidence that the same identifier will never be unintentionally created by anyone to identify something else. Information labeled with UUIDs can therefore be later combined into a single database without needing to resolve identifier conflicts. UUIDs were originally used in the Apollo network computing system and later in the Open Software Foundation's distributed computing environment, and then in Microsoft Windows platforms as globally unique identifiers. Other significant uses include X2X4 file system user space tools, LUKS encrypted partitions, GNOME, KDE, and Mac OS X, most of which either use the LibUID library now provided by the Util Linux package or implementations derived from it or from the original implementation by Theodore Tzlo in the eToFSprogs package. UUIDs are documented as part of ISO IEC 11578-1996 Information Technology Euro Open Systems Interconnection Euro Remote Procedure Call, and more recently in ITUT Rec. X667 ISO IEC 9834-8 2005. The IETF has published the standards track, RFC 4122, that is technically equivalent with ITUT Rec. X667 ISO IEC 9834-8. Definition: A UUID is a 16-octet number. In its canonical form, a UUID is represented by 32 lowercase hexadecimal digits, displayed in 5 groups separated by hyphens, in the form 8-4-4-4-12 for a total of 36 characters. For example, 123E4567E89B12D3A456-426,655,440,000. The first 3 sequences are interpreted as complete hexadecimal numbers, while the final 2 is a plain sequence of bytes. The byte order is most significant byte first, Sec 4.1.2. This form is defined in the RFC, Sec 3, and simply reflects UUID's division into fields, Sec 4.1.2, which apparently originates from the structure of the initial time and Mac-based version. The number of possible UUIDs is 3402823669209384634633, 374607431768211456, or about 3.4, 1038. Variants and versions. The variant indicates the layout of the UUID. The UUID specification covers one particular variant. Other variants are reserved or exist for backward compatibility reasons. An example of a UUID that is a different variant is the nil UUID, which is a UUID that has all 128 bits set to 0. In the canonical representation, the most significant bits of n indicates the variant. The variant covered by the UUID specification is indicated by the 2 most significant bits of n being 1, 0. The variant covered by the UUID specification has 5 versions. For this variant, the 4 bits of m indicates the UUID version. Version 1, conceptually, the original generation scheme for UUIDs was to concatenate the UUID version with the MAC address of the computer that is generating the UUID, and with the number of 100 nanosecond intervals since the adoption of the Gregorian calendar in the West. This scheme has been criticized in that it is not sufficiently opaque. It reveals both the identity of the computer that generated the UUID and the time at which it did so. Its uniqueness across computers is guaranteed so long as MAC addresses are not duplicated. However, given the speed of modern processors, successive invocations on the same machine of a naive implementation of a generator of version 1 UUIDs may produce the same UUID, violating the uniqueness property. Version 2 UUIDs are similar to version 1 UUIDs, with the first 4 bytes of the timestamp replaced by the user's POSIX UID or GID and the upper byte of the clock sequence replaced by the identifier for a local domain. Version 3 UUIDs use a scheme deriving a UUID via MD5 from a URL, a fully qualified domain name, an object identifier, a distinguished name, or on names and unspecified namespaces. Version 3 UUIDs have the form XXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXX UUID. To determine the version 3 UUID of a given name, the UUID of the namespace is transformed to a string of bytes corresponding to its hexadecimal digits, concatenated with the input name, hashed with MD5 yielding 128 bits. 6 bits are replaced by fixed values. 4 of these bits indicate the version, 0011 for version 3. Finally, the fixed hash is transformed back into the hexadecimal form with hyphens separating the parts relevant in other UUID versions. Version 4 UUIDs use a scheme relying only on random numbers. This algorithm sets the version number as well as 2 reserved bits. All other bits are set using a random or pseudo-random data source. Version 4 UUIDs have the form XXXXXXXXXXXXXX for XXXYXXXXXXXXXXXXXXXXXX where X is any hexadecimal digit and Y is one of 8, 9, A, or B. Version 5 UUIDs use a scheme with SHA-1 hashing. Otherwise it is the same idea as in version 3. RFC 4122 states that version 5 is preferred over version 3 name-based UUIDs, as MD5 security has been compromised. Note that the 160-bit SHA-1 hash is truncated to 128 bits to make the length work out. AIXM addresses the example in Appendix B of RFC 4122. Implementations. ActionScriptor, CASA-lib provides a version 4 UUID function as part of the stringutil class. Adobe Flex also provides a UUID implementation with a widgetil class. Apache Solr, SOLR contains a UUID data type. Car, on Linux, libuid is part of the util Linux package since version 2.15.1. The OSSP project provides a UUID library. C++, a object-oriented ID provides a C++ concrete type, that is designed to behave much like a built-in type. UUID is part of the C++ Qt framework. Boost UUID is a header-only implementation under a non-reciprocal open-source license. Catcher Copyright Object Scripter, UUID version 4 implementation for Catcher Copyright Object Script. Cake PHPA, CACIP will automatically generate UUIDs for new records if the table's primary key data type is set to char, 36. Cassandra uses version 1 UUIDs for a data type called timoid for use in applications requiring conflict-free timestamps. A standard UUID data type is also provided. Coco Carbona, the core foundation class CFUIDREF is used to produce and store UUIDs, as well as to convert them to and from CFSTRING and SSTRING representations. Since Mac OS X 10.8 and iOS 6.0, the NSUUID class is available. CFMLA, the create UUID function provides a UUID in all versions, however the format generated is in 4 segments instead of 5 XXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXXX A new GUID can be generated by pressing Ctrl plus Shift plus G. For runtime functions, see the Free Pascal and Lazarus IDE section. Common Lisper. Two libraries are available to create UUIDs according to RFC 4122. UUID creates V1, V3, V4 and V5 UUIDs. Uniquely creates V3, V4, and V5 UUIDs. CouchDB. If not provided, CouchDB sets the document ID for each document to be a UUID, DA. The Tango standard library includes a module to create UUIDs according to RFC 4122. Evala, a library is available to create UUIDs, generates UUIDs according to RFC 4122, variant 10, version 4. Source available at Eiffel UUID library. Elanga, Elang UUID and UUID implement UUID generation for versions 1, 3, 4, and 5 from RFC 4122. The V1 UUIDs generated are Elang PID specific. EXTJS. EXTJS implements UUID class as a generator to create data identifiers. Firebird Server. Firebird has gen UUID from version 2.1 and UUID to char and char to UUID from version 2.5 as built-in functions. Free Pascal and Lazarus IDEA. In Free Pascal there is a class called TGUID that holds the structure of a UUID. Also in the cctls par unit there are methods to create, compare and convert UUIDs. They are create GUID, GuitoString and is equal GUID. In the Lazarus IDE you can also generate a UUID by pressing Ctrl plus Shift plus G. Goa. The GUID package provides, in pure Go, immutable UUID structs and the functions new v3, new v4, new v5 and parse for generating versions 3, 4 and 5 UUIDs as specified in RFC 4122. Haskell. The package UUID directly implements most of RFC 4122. The package supports generation as well as serialization to and from string and binary formats. The package system UUID provides bindings to the native UUID generators on Windows, Linux, FreeBSD and Mac OS X HAXI, HEGS functions which generate version 4 UUIDs as defined in the RFC 4122 specification. IOSA, CFUUID and NSUUID can both be used to create UUIDs in Objective-C. Java. The J2SE 5.0 release of Java provides a class that will produce 128-bit UUIDs, although it only implements version 3 method, and 4, generation methods, not the original version 1. The API documentation for the Java util UUID class refers to ISO IEC 11578 1996. Alternative open-source libraries supporting MAC addresses on several common operating systems include UUID Eurogenerate UUIDs in Java and Java UUID Generator. JavaScripter. Bruffer.com has implemented a JavaScript function which generates version 4 UUIDs as defined in the RFC 4122 specification. An open-source library UUID.js, which is available under the MIT license, generates version 4 and version 1 UUIDs according to RFC 4122. Another open-source library, Node-UUID, also generates version 4 and version 1 UUIDs, and is available through the NPM and Component.js package managers. Kohanavpa, the Kohana PHP framework, supports the generation of version 3, 4, and 5 UUIDs according to RFC 4122 specifications using the UUID module. Lasso, a custom tag for Lasso 8 Plus by Douglas Burchard, an LJ API module by Stefan A. Klein, also for Lasso 8 Plus. Lasso 9's implementation of Lasso UniqueID also returns a UUID. Livecode, Lua, there is a Lua module by Luz Enrique de Figueiredo. Mac OS X, command line utility Origin is available. Microsoft SQL Server, Transact SQL provides a function called NEWID to generate unique identifiers. SQL Server 2005 provides an additional function called new sequentialid which generates a new GUID that is greater than any GUID previously created by the new sequentialid function on a given computer. MySQL provides a UUID function. .NET Frameworker. The .NET Framework also provides a structure system GUID to generate and manipulate 128-bit UUIDs. OCaml, the UUIDM library implements universally unique identifiers version 3, 5 and 4 according to RFC 4122. Oracle Database. The Oracle database provides a function SYSGUID to generate unique identifiers. Perl. The data UUID and data GUID modules from CPAN can be used to create UUIDs. The UUID Tiny module is a lightweight, low-dependency pure Perl module for UUID creation and testing. PHP. In PHP there are several modules for creating UUIDs. PostgreSQL supports UUID as a native data type. For generating UUID values, functions may be added as a commonly available UUID OSSP extension based on the OSSP library. Progress OpenEdge Appler. The Generate UUID function in OpenEdge 10 provides a UUID which can be made printable using the GUID or BASE64 encode functions. Python. The UUID module creates UUIDs according to RFC 4122. Revolution Run Revan, the libuid library, a library that generates UUIDs of Type 1, Type 3 and Type 4. Version 1.0 by Mark Smith. OSL 3.0, Ruby. There are several RFC 4122 implementations for Ruby, the most updated ones being Ruby UUID, UUID and UUID tools. Ruby 1.9 includes a built-in version for UUID generator. SAP Business Objects Data Servicer. The ETL tool SAP Business Objects Data Services contains a function to generate a UUID, GenUID. TCLA. A TCL implementation is provided in the TCL lib package. Unix. Command line utility AIXM may be provided by default. There is also a tool called Simply UUID available, which is the same functionality. The FreeBSD and Linux kernels have a built-in UUID v4 generator too. To use this on Linux, you have to read the file sysrandom UUID. On FreeBSD there is a simple system call AIXM, too. FreeBSD also has Linux sysrandom UUID as part of its Linux emulation. Random UUID probability of duplicates. Randomly generated UUIDs have 122 random bits. Out of a total of 128 bits, 4 bits are used for the version, and 2 bits for the variant. With random UUIDs, the chance of two having the same value can be calculated using probability theory. Using the approximation. These are the probabilities of an accidental clash after calculating n UUIDs, with x equals 2122. To put these numbers into perspective, the annual risk of someone being hit by a meteorite is estimated to be 1 chance in 17 billion, which means the probability is about 0.000000000006, equivalent to the odds of creating a few tens of trillions of UUIDs in a year and having one duplicate. In other words, only after generating 1 billion UUIDs every second for the next 100 years, the probability of creating just one duplicate would be about 50%. Or, to put it another way, the probability of one duplicate would be about 50% if every person on Earth owned 600 million UUIDs. However, these probabilities only hold when the UUIDs are generated using sufficient entropy. Otherwise, the probability of duplicates could be significantly higher, since the statistical dispersion might be lower. History. The initial design of DCE UUIDs was based on UUIDs as defined in the network computing system, whose design was in turn inspired by the unique identifiers defined and used pervasively in Domain OS, the operating system designed by Apollo Computer, Incorporated. See also, Globally Unique Identifier, References. External links. International Standard X667AA Euro Generation A Euro of Universally Unique Identifiers A Euro, International Standard Generation and Registration of Universally Unique Identifiers and their use as ASN1 Object Identifier Components, ISO IEC 9834-8 2008. Generation and registration of universally unique identifiers and their use as ASN1 Object Identifier Components, a universally unique identifier earn namespace, extract the time from a version 1 UUID/GUID, global UUID registration function at ITUT, commons ID, DMA-ID for instance ID values, syntax and semantics of the DCE variant of universal unique identifiers, random UUID probability of duplicates, ITU registration of UUIDs and representation of a UUID as an OID. A universally unique identifier is an identifier standard used in software construction, standardized by the Open Software Foundation as part of the distributed computing environment. The intent of UUIDs is to enable distributed systems to uniquely identify information without significant central coordination. In this context, the word unique should be taken to mean practically unique rather than guaranteed unique. Since the identifiers have a finite size, it is possible for two differing items to share the same identifier. The UUID is represented by 32 lowercase hexadecimal digits, displayed in 5 groups separated by hyphens, in the form 8-4-4-4-12 for a total of 36 characters. For example, 123E4567E89B12D3A456-426,655,440,000, the first 3 sequences are interpreted as complete hexadecimal numbers, while the final 2 is a plain sequent technology a Euro Open Systems Interconnection a Euro Remote Procedure Call, and more recently in ITUT Rec. X667 ISO IEC 9834-8 2005. The IETF has published the standards track, RFC 4122, that is technically equivalent with ITUT Rec. X667 ISO IEC 9834-8. Definition: A UUID is a 16-octet number. In its canonical form, a UUID size and generation process need to be selected so as to make this sufficiently improbable in practice. Anyone can create a UUID and use it to identify something with reasonable confidence that the same identifier will never be unintentionally created by anyone to identify something else. Information labeled with UUIDs can therefore be later combined into a single database without needing to resolve identifier conflicts. UUIDs were originally used in the Apollo network computing system and later in the Open Software Foundation's distributed computing environment, and then in Microsoft Windows platforms as globally unique identifiers. Other significant uses include X2X4 file system user space tools, LUKS encrypted partitions, GNOME, KDE, and Mac OS X, most of which either use the LibUID library now provided by the util Linux package or implementations derived from it or from the original implementation by Theodore Tzlo in the eToofsprogs package. UUIDs are documented as part of ISO IEC 11578 1996 information